Hi there, welcome back to the channel. Welcome to another video in the restoration of the Braun TS2. Now what I did in the last time was try to get the AM to work, and to do that I thought there was something wrong with the oscillator circuit. I didn't realize it was just a wire that was loose, and I did mess around with all the settings on the oscillator stage and the RF stage underneath the chassis. So the first thing I wanted to do now is try and get that back to where it was before, and that requires an RF alignment. Now this is normally done after an IF alignment, but because I wasn't sure what I had done, I wanted to do the RF alignment first, and that's what I'm going to start with here. So RF alignment of the AM bands, and the problem that I ran into was that the instructions that I have are for a different chassis to this one. It's for the RC62 and this is the RC61, and I found that the components or the description of the alignment was different. So what I decided to do here is to actually create or check and reproduce the alignment instructions for this particular set as regards the RF alignment, because that's the one where the differences are pretty obvious. So I did a translation, I did a check, I did a new drawing, I've pointed out all the coils and all the trimmers that you need to work on, and then I do the alignment itself. And then of course at the end of this video I'm going to actually do the IF alignment, which is really simple on this radio, and it's not different from the RC62, so I didn't need to do much translation on that. The one thing I did find is probably the first time I've actually noticed this is a really bad front end for the shortwave. It doesn't do much in terms of rejecting the image frequencies, and quite honestly I was a bit stumped on this because I had an idea of the image frequencies in my brain. This thing was exhibiting a different type of characteristic or different type of behavior. So it took a bit of thinking, and I'll go through that and show you what it is that I did and what I can do and what I can't do. So if this sort of thing interests you, stick around, enjoy the video. But before we continue, I just want to thank the sponsors of the video, PCBWay. They're the guys that do all the PCBs for the projects that I show on this channel. And as is obvious, for my needs, it's mostly the PCBs, and mine are normally simple double layers. And the quality is amazing. The choices of materials, thicknesses, colors, and everything else is incredible. So you just upload your Gerbers and you get yourself a quote, and then you choose your shipping options and so on, and they are incredibly fast. But the one thing I noticed recently is they've got an order status indicator, which is quite cool. This is my latest order, and I've always seen this here, but I didn't really know what it was. And obviously this one is completed, but it shows every single stage of the procedure. And if you want, you can actually click on here, and they've got videos showing what that procedure entails, which is really cool. I watched a few of these. I hadn't seen these before, and I thought they were pretty interesting. So you can actually get an in-depth view of every stage of the order process. And I've taken some screenshots of this particular order as it was in execution, and you can see that this was not 100% at the time. I just thought that was pretty cool. So whether you need the simple PCBs or whether you want them to be assembled by them, which means they give it to you with all the components on it, be it surface mount or through hole, or whether you're looking for CNC machining or 3D printing, go to PCBWay. I'm sure you'll find something for your needs. I'm going to proceed now with the RF alignment, and as I said in the last video, this is a little bit backwards. I should do the IF alignment first, but because I messed with these guys when I was trying to get the oscillator to work, thinking that perhaps it was some setting in the tuning there, I want to sort of set it right first. I also mentioned that the instructions I have are not for this particular radio. It's for the RC62, which was from the Braun Atelier 1 that I did before. So I had to sort of go through the schematic and do some checking on the actual contacts here to be able to redraw the adjustment points. And I've done that. And let me show you what the result is and what we need to do. What I've done is I've taken the German instructions for the RC62 for the other radio, not this one, and I have followed the same order, but I've made sure that I've checked everything correctly as applies to this particular chassis. And so what it tells us is it's RF alignment and peaking. When using inaccurate test signals or signal generator, recommended to correct the scale calibration using known transmissions. Now, obviously, this, when they talk about inaccurate test generators, if you've used some of those old generators, you know that when you set the frequency on the dial, it's an approximate frequency. It's not that accurate. Now, I'm using a Rigol digital signal generator, so that is absolutely accurate. I don't need to worry about checking that it corresponds to a particular station. And what they mean here is If you've got a station that you know the frequency of, like we've got one known AM station in Madeira, it's at 1530 kilohertz. So if I went to 1530, I can make sure that it's tracking the right place. So then we need to check the end position of the scale pointer. Because those dial pointers actually move on that string with the spring and all that, you actually need to make sure that it's in the right place, because if you've got it too far to the right at the top and it's too far to the right on the left, it means the alignment, the actual RF alignment might be perfect. You just need to sort of shift the dial pointer on that cord, on the dial cord a little bit, and you've got everything right? So there's a marker on the radio. I'll show you when I do it. There's a marker there that tells you that's the right end of the scale and the left end of the scale. So make sure that you align it. In this case, they tell us to align it or adjust it to the right side of the scale division. Then we start with the first band, and that's shortwave. These are now correct, okay? And these correspond to a drawing that I've made, this drawing here. Okay, so let's go one at a time. Align the oscillator coil A, which is spool 12, coil 12, at 7 megahertz, and the oscillator trimmer B, which is capacitor 29, at 14 megahertz. So at the bottom end of the frequency range, you set the dial pointer to 7 megahertz, and you adjust A, which is coil 12, till it corresponds to 7 megahertz. Then you go to 14 megahertz and you adjust B till it corresponds to 14 megahertz. So you're basically adjusting the position of the dial to make sure that is correct. But that is not enough, because you've also got an input circuit, if you recall, and you peak that, you leave it at 7 megahertz, for example, getting the signal, and then you peak it using adjustment C, which is coil 8 at 7 megahertz, and then you do the same at 14 megahertz. You tune it to 14 megahertz, make sure that it's nicely aligned at 14 megahertz, and then you go to capacitor 24 and you peak it with adjustment trimmer D. So you see, if you look down here, this is what I've got. A, remember I told you that was the oscillator coil for the shortwave. So that's adjusted at 7 megahertz. Make sure it gets to 7 megahertz exactly. Then you move to 14 megahertz and you do this one here, which is a trimmer capacitor, and you adjust that so that the dial point and the signal at 40 megahertz correspond exactly. And then you've got to go to the front end, and these two are the front end. So C, which is coil 8, is that guy over there, and D, that trimmer, is that guy over there. So if you wanted to do them simultaneously, which I normally don't do, normally I adjust the frequency adjustment at the bottom end, which is this one here, and the frequency adjustment at the top end, this one here, and then I go back to the bottom end and I adjust the front end, and I go to the top end and adjust the front end as well. You can do it either way. The other way, of course, is you do that front end corresponding to that front end, so you adjust the frequency and you peak it, and then you do the 14 megahertz, adjust the frequency, and you peak it. But because these two, the bottom oscillator adjustment and the top oscillator adjustment, you normally have to go backwards and forwards and just correct it every time, because this one affects that one and that one affects that one. I prefer to fix the frequency first and then go to the front end. But that is the shortwave, and I've marked these in orange. Now the picture we had in the other service manual, you couldn't see it all. So the idea is that this will serve as a reference. If you want this, do a screenshot. I'm not going to be sending this. I'll just refer you to the video. I'm sure it's clear enough. So that was shortwave. Then we go to medium wave, and in medium wave they say at 575 kilohertz, the calibration point is Stuttgart. So if you can't see the pointer, there's actually a little pointer there on the dial. I'll point that out when I do it, but they do tell you that it is Stuttgart. Now Stuttgart's quite a long band, a long span, but it just gives you an idea of where it should be. You align the medium wave oscillator coil E, which is coil 13, to adjust the frequency, and you peak the oscillator coil at adjustment F, which is coil 9. So we're talking about E and F. E and F. E is over here. This is the oscillator coil. F is the front end coil. So those two. That is at 575 kilohertz. Then you move up to 1439 kilohertz, calibration point Luxembourg. Medium oscillator trimmer is point G, which is capacitor 31, and you peak it at capacitor 27, which is 0.8, so G and H. Here we've got it. G is the oscillator and H is the front end. Again, the medium wave is a different color, so it's in yellow. Then we go to the long wave, and long wave is different. It's only got one adjustment point. You set it to 200 kilohertz, and when I say you set it, it means you feed a signal into the antenna at those frequencies, right? This is receiving from the antenna. So 200 kilohertz, align the long wave oscillator coil at point J, which happens to be coil 14. There is J. Remember I said that was the oscillator coil. Then you've got a peak, front-end peak at coil K, which is 11, that point over there. So you adjust the frequency and you peak it, and for long wave, that sort of spreads across the whole band. There is no lower and upper adjustment. Now, as you can see, it's very simple, but trying to figure out which ones they were, it was a little bit of a mission, but I wanted to put this down so that if you want to, do a screenshot and you've got all the information you need. Now I'm going to go back to the radio and do this. It should be quite easy. So let's do the prep work. I've got the signal generator set to 7 megahertz. Amplitude, I've got it at the minimum this will allow. I've got modulation on. It is AM modulation. I put a depth of 50%, 1 kilohertz tone. That's what we should be hearing. And that's coming out of that channel. It's coming to the switch attenuator coming in there. There's no attenuation at the moment because I don't know how much I'll need, but if I do need it, I'll just set it. I'm going to set the dummy antenna. Remember, this is going to tune the front end, so it would be a good idea to have the signal coming in from the signal generator look like it's coming from an antenna. And I've connected that to the AM antenna sockets over there. I'm going to select shortwave, and I've got this meter monitoring the output of the speaker. Now, instead of going straight to here, because this has got a 2.5 volt range, I'll probably need to go a bit lower. I don't want to blast this. I've got my multiplier over here. This multiplier is actually receiving the signal. It multiplies it by 2, 5, or 10, depending on how much I need to see it nicely on the scale over there. I normally like to multiply it so that I can get this more or less in the middle of the scale. It makes adjustments a lot easier. And that's it. I'm ready to go. I'll flip the radio on its back so you can see me make the adjustments, and we'll see the reading on the scale there, so you'll see the results of the adjustments. So we're talking about that guy over there. And I'm just listening for it. This is doing all the whistles and buzzes and all that, which I don't like, but it's on frequency. Okay, that's the 7 megahertz done. I'll do the frequency first, and then I'll come down and do the front end alignments. Now we'll set that to 14 megahertz. Try and find it at 14. Remember, 14 is over here. Oh, volume up. There it is there. Give it a bit more amplitude. So where are we? 10, that's close. I guess I want it there. And I know that it's that guy over there according to the instructions. There we go. Now what I'm going to do is put it back to 7. That's what I'm doing now. 7 megahertz. Go up to 7 again, see if I need to adjust the other one. No. Well, I guess a little bit. A little bit. So we'll adjust 7 again. And now I'll do 14 again. See what I mean about going backwards and forwards? And what we're seeing here is the oscillator signal. And I'm reading down here 14.4 between 5 and 7. So this is 14,460. So, well, we know we're at the right place, at least. And what I'll do is I'll check this one again, and check that one again, and check this one again. Make sure I get the frequency absolutely right. And then I'll come back and do the front end alignment. Okay, here we go. We can hear it. I'm going to just put this on dummy load so we don't have to get blasted by it. And now what I need to do is I'm going to be looking at the meter, and I want to peak the front end. Now the front end, we know at the 7 megahertz, which is where I'm tuned to now, I've adjusted the frequency. Now I need to adjust this guy here for a peak. So we will check the meter. No, that's going down. There's our peak. Not much to it, okay? Now back to 14 megahertz. Set that on the signal generator. I'll put the sound on again so we can hear it. Tune to 14. There's 14. Put the tone off again. We don't need to hear that. And we'll go to, which one was it? This guy. Now we'll watch the meter. Oh, there's the peak. See that? There's a massive peak over there. Goes up and then goes down. So there is our peak. And we've peaked the front end. Now I do need to do the other one again, because this is, I'm putting it back to 7 megahertz. And I'm going back to putting the sound on, go back to 7. Got the volume on too high, the meter's tripping. Put it like that, get rid of the sound, and we'll see if we need to peak this guy again. Yeah, see, it's messed the whole thing up. There's our peak now. Now we'll put it to 14 again. And get some sound, because we need to hear when we've tuned into it. Up to 14. There we are. Sound off, put it on dummy load. And now we'll see what this guy wants. You see, it's a twist. There's our peak. And so I need to go backwards and forwards between that one and that one, that one and that one, till I get them both to peak. I won't bore you with that. I'm going to do that. This is going to take 3, 4, 5, 6 times, however many times, backwards and forwards, changing it to 14 to 7 and adjusting that one, changing it to 14 and adjusting that one, and getting the front end totally aligned and peaked. Okay. All right, the shortwave is complete. I just want to show you what the tracking is like. I'm going to I have set the signal generator to 10 megahertz. There's 10 megahertz. Let's see where we pick it up. It's just slightly off to the left. Let's try 12 megahertz. Again, just slightly to the right. So anyway, the tracking on shortwave seems to be pretty good. I'm going to quickly show you the tracking on the medium wave and long wave, because I've done that. I don't want to repeat the whole thing again. It's really exactly the same thing as I did for the shortwave. You just follow the instructions, make sure you're getting the right adjustment points. But really, there's no mystery. But I'll just show you what the alignment is like. On medium wave, they told us to set it at 575 and 1439. Rather strange frequencies, but if you look at the medium wave band over here, there's a little blip on the dial over there. And then over here, there's another little blip on the scale over there. Those are the adjustment points. They tell you what frequencies they are. So I've aligned the two end ones. But let's go to the middle here. Let's go to 900 kilohertz. That's what I'm sending from the signal generator, 900 kilohertz. Near as damn it, it's exactly on there, 900. So that alignment is fine. With the medium wave, we had the oscillator top end, oscillator bottom end. We had the front end top end and front end bottom end. So we had 4 adjustments there as well. It's very clear on the instructions. Now, if we go to long wave, we've got one alignment only, and that was at 200, which is over here. So I'm going to try, say, 260. Setting that on the signal generator, 260, put the volume up. Yep, it's perfectly on there. Okay, now that this is all done, I want to show you something on the shortwave, which is a little bit disconcerting. Remember, I had a frequency over here, 14 and 7, okay? Now let me put this on, say, 10 megahertz again. It's on 10 megahertz. There's our signal, right? But let me track to the left and see what happens. Nothing. Okay, there's 10 again. Let me track to the right and see what happens. Ah, you see that? I'm getting an image there. And this is a little bit strange. I'll explain why I got a bit confused here. Normally when you get image frequencies coming through, it's because the front end is not a very sharp tuning. You're not filtering the front end properly. So when you have it on 10 megahertz, your oscillator is set to 10.46. In this case, because our IF frequency is 460. So when your oscillator is set to 10.46 megahertz, it mixes with 10 megahertz, and the oscillator frequency minus the input frequency, the station frequency, gives you 460. So you get the station that's at 10 megahertz. But you'll also get another station. And that is because you've got 10.46 megahertz local oscillator. What if the signal at 10.46 plus another 460 comes through? You would get that coming through as well. That's called an image frequency because your front end isn't properly tuned. What I was getting here is different. I'm getting it at 10. I'm getting it at 10. And I know that's 10 because that's what my signal generator is sending. And with the signal generator still sending 10 megahertz, I'm getting it here. Now, what frequency is that? Well, let me find out. I can start dropping the frequency. And I know it's over 2. I can already hear some of it here. But let's refine this a bit more. There we go. It's 9.08. Now, that's not the frequency that's coming through. What I'm trying to show is that our 10 megahertz signal is being picked up at 10 megahertz and also at 9.08 megahertz. Now, what does that mean? What are we seeing here? I've still got the signal at 9.08, and I want to see what the oscillator frequency is there. And the easiest way to do that is to put this in here again and look at the scope and see what frequency it's pumping out there, the oscillator. And we can see that when we tune to 9.08 megahertz, our oscillator frequency is 9.54 megahertz. So I'll make a note of that. So what we're getting here is this. When we have our frequency coming in at 10 megahertz, that's Fi. Our FO, F oscillator, FO, is 10.46. We know that. That means that the mixer, which creates the sum and the difference and 2 times the sum and 2 times the difference, it produces all sorts of mixed products over here. But the one we're interested in is this one here, which is 460 kilohertz. That's why we hear it, because this goes through the IF chain. This is the important thing. When the oscillator is 460 kilohertz above the input frequency, it produces 460 kilohertz out. So whatever signal, whatever information is on Fi, on the station at Fi, you're going to get that coming out. So what we had here was 10 megahertz. We had here 10.46. And the difference went through, the sum is too high. The difference goes through and it comes out of here. Now, what have we got with this guy over here? Why are we tuning to 9.08 on the band and picking up the signal that we're feeding at 10 megahertz? Well, it actually works out pretty well. We've got the same 10 megahertz here, coming in here. Now, what we've got at the oscillator when we tune to 9.08 is we've got 9.540. Now, if we take FO minus FI, we get a negative number here. But the point is this. The mixer doesn't care whether this is higher or that is higher. It just subtracts the higher from the lower. The difference is between the higher frequency and the lower frequency. When we are working with our normal system, our oscillator frequency is higher than the input frequency. But this mixer doesn't really know that. It just takes one signal, subtracts it from the other. It also adds it, like it did with our normal situation. So what it's done here is this. It's taken our 10 megahertz, minus 9.54, and guess what you get? You get 460. Which means that the difference in the case when the oscillator is 9.54 megahertz, the difference between it and the input frequency at 10 megahertz is 460 kilohertz. So the station at 10 megahertz will come through. And it's an image frequency, it's again the image frequency on this setting, because we are getting two, in this case we're getting the same station on two frequencies. Normally what you talk about when you talk about image frequency is when you set to a frequency, you are getting two stations on the one setting. This is slightly different. Okay, let me repeat that. You are getting you are getting the same station on two frequencies, and normally you would talk about imaging as getting two stations on one setting. Okay, so that's why we're getting this imaging, and the reason for this is that our front end filter is not very sharp. It probably should be, you know, like this. Instead, it is pretty lax. And I don't really know what to do about that. In fact, I don't even know that you can do anything about that. Actually, I'm sure you can't do anything about that, because the circuit that's here is exactly what is described in the schematic. Our front end is as simple as it can be. You know, the signal comes into a tank circuit, which is made up of this coil, this trimmer, this little capacitor over here, which is making up the right capacitance that you can adjust through, and of course, the one gang of the tuning condenser. So this thing is not very sharp. It's got a low Q, I suppose, but there is nothing here. I can't see. There are no resistors here that would have dropped the Q, you know, made the filter flatter or something like that, less sharp. I don't think you can do anything about this. I think this is just the nature of the beast. This particular front end filter on shortwave, mind you, this is only on shortwave, because the front end of medium wave and long wave is a different circuit altogether. So that's it. That's one of the shortfalls. The difference in signal strength between what I'm getting when I'm tuning to 10 and when I'm tuning to 9.08, it is fairly significant. But as you saw, it's fairly audible. It's very clear. So I don't think there's much we can do about that. And I've actually looked at the RC62, the Atelier 1, and I believe it's exactly the same. It could simply be the quality of the wire they've used on here, which may have more resistance, and therefore it would create a flatter curve on that filter. I don't know. Anyway, that stumped me for a bit, because I was thinking of image frequencies as picking up a higher frequency, and it's exactly the same concept, and it's very, very simple, but I thought I'd let you know. Okay, onwards. As I said earlier, I'm doing this a little bit backwards, because now I'm going to do the IF alignment, and they tell us to set the radio to medium wave, and they tell us to set the dial to about 700. Make sure there's no station there when you set this up, and then we're going to look at the back, and I'll show you how I do the alignments. It's very, very simple. I've actually just switched the radio off because they tell us to send the signal. Actually, they tell us various things. I'm doing this the simplest way. I'm going to feed the signal to the grid of the ECH81. The signal will be a 460 kilohertz signal with a tone on it, and the amplitude I'll adjust to try and get this fairly low. They tell us we measure from the output across the speaker on about a 1.5 volt range. You don't want the signal to be very high, otherwise it affects the automatic gain control. You don't want that. So you make it very, very low as you can in terms of amplitude, so you can just hear the tone when your volume is on max. Now, the way I feed this signal in here, I've done it various ways, but this is the ECH81. And the way I prefer now, I'll probably change in the future, is I built this up. I managed to buy one of these things. It's a socket. It's a socket saver, they call it, for this type of tube. And I've soldered a little wire to pin 2, which is the grid. And now let me just get this in here. So I'm putting this in here as if it were the tube. And I'm going to connect this to a ground, and the ground will just be anything metallic nearby. Well, metallic connected to chassis nearby. That'll do. And this leaves me with these 2 points for the signal generator. The yellow is the signal, and that is just ground. It's just connected to the chassis. The only connection I've got to that tube socket is pin 2, which is our grid, which is where we're going to feed this signal into. Now let me get this right. There we go. We don't need to go on the underside or anything like that. Signal generator. There's the signal itself. There's the ground. I just made these covers so that this doesn't accidentally short anywhere. Now all we need to do, I've got the speaker here. I've got my meter across the speaker. I've got the multiplier here. I'll just set it up. I'm going to set it fairly strong so I can hear it, and then I'll adjust the amplitudes accordingly. So signal generator, 460 kilohertz, modulation, depth 30, a tone of 1 kilohertz. The amplitude is at a minimum. It's going out through my switch attenuator, which is, this time it doesn't have the dummy antenna activated. This thing has got a capacitor coupling, so it's not DC coupling. So that's all set. I'm going to switch on the signal generator, and it is too high. So I'm going to drop the amplitude, give it quite a bit of attenuation, putting the volume up higher. It was really, really loud. It's probably a little bit too low. That's probably the way I want it. I could give it more attenuation, but I want to hear the tone. And now we'll look at the meter. I'll set the speaker to dummy load so we don't have to listen to that. And the adjustments you need to make are very simple. It's literally 1, 2, 3, 4, and we want to peak that. So we'll just start doing that. Look at the meter. Sometimes seeing this is more difficult than doing it. There we go. That was pretty much peaked. Bottom one. We got a little bit out of that one. A little bit more out of that one, I should say. And a bit more out of that one as well. That's it. Our IF is done. Now, obviously, what you need to do is do this a couple more times. Make sure you get the most, squeeze the most juice out of there. And that is our IF alignment done. So we've now completed 2 stages in the process. We've done the RF alignment. This time we did it first. And we've done the IF alignment for the AM bands. And that really is the end of the AM bands, unless something goes wrong with one of those capacitors that I mentioned. But I'm hoping not. And the next step, of course, is going to be the FM. And the FM, I actually haven't tried it yet. I noticed this thing was a bit loose, so I'm a little worried about that, but it shouldn't be a problem. But I'll be doing that and showing you the result in the forthcoming video. So I do hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, please do so on Patreon and PayPal. Links are in the description below. So once again, thanks for watching. Bye for now. And most of all, stay safe.